Hello friends, welcome to my channel Code Blocks. I came here once again with a new video. So today's topic is something new and it's interesting, and it is linked list, the most important linear data structure. So you can see here, this is a head node that represent the first node of this linked list. This is totally a linked list. In this linked list we have totally three nodes. One is here, this is the first node, this is second, and this is third. And each node contains two parts. One is data part and one is next part. The data part contains the data, or you can say the value, and the next part contains the address of the next node. You all know about that. So first of all, I go to the coding part, and then I can understand you how to insert the element and how to insert a element inside the linked list. So first of all, write the header files. And has include stdlib.h, and this header file I am written here stdlib.h. You all know what is stdlib.h, and this is something new. stdlib.h, this is for malloc and create. That means whenever we create memory, dynamically we create memory by using malloc or calloc function, then we have to define these header files. And after that, now, and as you all know that we can create linked list by using structure. So I have to write the struct keyword and then node, and inside it I have to write two parts. One is data, integer data, and one is the next part, struct node next. And this next part pointing to the contain the address of the next node. And after that I am writing the head node, struct node head, and initialize it with null. Because first of all, the head node is does not contain and does not represent to any node. It itself a single node, and it represent the first node of the linked list, and at first it's only just a single node that pointing to nothing. That means here that's why I enlisted here head is null. Now I am writing here the main function, integer main. I am writing character ch, as I told. First of all, I have to told you that I have to insert a number of element. I think it's n number of element into the linked list at any position. That means nth position. In this video, I tell you how to insert n number of elements at nth position. That means at any position in the linked list. So for all this I have to use do while loop. First of all, the insert function, and thereafter display the elements, and thereafter I have to use one more thing, printf. Do you want to add add a element and another element? This is asking the user whether he or she add another element or not. Okay, and to read the input from the user, I am using the get ch function. Ch is equal to get ch. This function are contained in sorry, this function this is a function that's contain, or you can say that reads a single character as an input. It reads a single character as an input from user, and it is present in stdio. It's present, it has include conio.h, has include conio.h. In this header file, this get ch function present, and it reads a single character as an input. And using this do while loop, and this in this condition I have to given ch not is equal to n or any other input. Whenever user given n input, then it exit the loop. That means it does not contain it does not he or she does not add any other element in this linked list. So now I have to create the insert function. Void insert, now I have to create a node. Struct node new node, and the node name is new node, and struct using malloc struct node pointer, and this malloc, and this is the size of struct node. This is how to write the malloc function to allocate a memory for a node. Now each node have two different parts, one is data part and another is next part. So I have to ask user to add the data part, or you can say the add the element. So printf enter a data, enter a data, scanf percentage d ampersand of, here I have to write the new node data, ampersand of new node data, and this will take from user the data element, and it also contains the next part that points to nothing initially. So new node next is equal to null. Initially it does not point to any other node. So now I have to ask user whether he or she add this value to the linked list. Printf enter a position, scanf. For that I have to declare a variable integer n, and now I have to give scanf percentage d ampersand of n. Okay, now the condition applied, whether he or she add the element, add the node at the either the first position or either the second or either the third. So if n double equals to 1, that means he or she wants to add the new node in the first position. For that purpose I have to do one thing, new node. So new node next part initialize with head, because first of all the as you see here, the first of all the head element, sorry, the head node pointing to nothing, that means null, and here initially the next node the next part of this node, new node, it also initialized to null. And whenever I have to create a position, I have to create a new node in the linked list at first position, the new node next always be represent to head. That means head equals to here pointing to null. That's why new node next pointing to null, and head pointing to new node. I think you have not understand yet well. So now comes to the picture. Here you can see that this is the head that point initially does not point to anything, and after inserting this element, this is the first element, after inserting this element, the new node next part, that means this part, new node next part initially is pointing to nothing, that means null. So that's why as head pointing to initially does not point to any other, that means heads initially pointing to null, and I am declaring that the new node, as you can see here, new node next is equal to head. That means head equals to, as head equals to null, that's why new node next is equal to null. That means after adding the new node next part pointing to null, and head equals to new node, that means after adding the first element in the linked list, the head element, this element represent the first element, that means pointing to first element. That's why it contains the 100 here initially, that is of the first node. And this node point first initially, after inserting the first node, it pointing to the first element. Okay, after that, if any user or any student or anyone wanted to add element not in the first position, or he or she can add this node at second or third position, in this case I have to create another node, struct node, and given as name as temporary variable temp, create a temp node and initially it initialize with head. And now using for loop I have to traverse the linked list. He or she does not want to add node at the first position, that's why I have to traverse the node. For I is equal to 1, I less than n minus 1, I plus plus, and inside this for loop I have to write temp is equal to temp next. Okay, and after this the temp next so you can see here, so I am writing here a new node, that means temp node. Okay, and it initialize with null, that means it initialize with head, that means it is represent to null. And the other parts I have to write new node next pointing to temp next, and temp next pointing to head. Okay, sorry, it's not head, it's new node, the node that I want to add here. So now suppose this is the these three elements, these three nodes are present in the linked list. I want to add a element at this position, that means second position. Okay, So this is our new node, that is the air data part is 11, and initially it pointing to nothing, and I have to add this is at second position. So comes here, I is equal to 1, I less than 2 minus 1, that means 1, and I is equal to 1 and I less than 1, it does not true, that means the for loop does not execute. And a temporary variable pointing to not head, that means it points to the first node. Okay, the temp variable, the temporary node pointing to first node. And now new node next is equal to temp next. So this is the new node, this is not our new node. So new node next pointing to temp next, and the temp node pointing to the first node. Okay, and is temp next, that means this point, and temp next part pointing to this node. So new node next part pointing to temp next, that means this part pointing to this node initially. That's why, and that's why this 200 written has here 200. And after that temp next is equal to new node, that means the temp next, that means this node, the second node, it represent to next new node, that means this. Okay, that means using this I have to break this line and add this temp next node, that means this part contains new node, that means this 600 letter it represent here. So using these two line I have to break this line, this part, or you can say this link, and I first of all I have to bonding here a link, new link, by new node next part pointing to temp next, as temp next pointing to this the second element. So that's why the this element pointing to the second element, and temp next, that means this part now pointing to new node, that means this. So I have to break another link here. Okay, so now see what the output give us. Okay, I have to create a function for display, void display. For this I have to create a temporary variable, a temporary node, struct node temp, initially it's pointing to head, that means starting from the first node, while temp node not equal to null, this is the condition. And I have to print all the elements, print a percentage d temp data and temp is equal to temp next. Okay, I am writing printf and the elements. Okay, elements of the linked list. And for good looking I have designed some here, and here I have to write printf null for good looking, or you can say by you can see, you can understand. Okay, enter a data 5, I enter data 5, enter position. As the first of all the link list is null, so I have to insert the data at the first position. So I write here 1, that means the first position. So the elements of the list here 5 null. So here okay, so you have to done here /n, this means line breaking purpose. Now enter data, I am entering 5, enter position, that means 1. The you can see here the elements of the linked list, this is 5 and null. The next part pointing to nothing, null. Do you want to add another element? If I write here n, that means it execute the loop. I am writing in the do while loop the condition. Here ch not equal to n. If I am writing any other than n, then it will print it will tell us that you can add another element in the linked list. So I have write here 6, enter a position. Suppose I am wanting to add this node at the first position, so I am enter the 1, and you can see elements of the linked list are that the 6 are insert in the first position. So it again asking user, do you want to add another element? If I write here n, so then it breaks the while loop and execute. That means it does not add any other element. Okay, so one more thing, 5 1 and 6, enter a position 1 1. Okay, and now I am writing 7, and I have to add this at the second position. Okay, so you can see here that the 7 is inserted at second position. So I think you can easily understand this. And if you even not understand this, the n is equal to 1, that means add is the first position, so comes here again. Okay, now so that means this is the new node, and I have to add this here. So first of all I have to break this line and add this one to this and this one to this. So first of all, the new node next is equal to head, that means this is our new node next part. This means initially it's pointing to nothing, that is null, and this is next node new node next pointing to head, that means initially head pointing to the first node, and after this new node next pointing to head, that means new node next part pointing to this, that means I am creating a internal link here. And after that head is equal to new node, that means now head representing this node, and it's break this and it does not, now it not pointing to anymore the first node of this linked list, and it pointing to this head is equal to new node. Now this line is break here. Now this line is breaking here, and we have created it. Now the head represent to this node, and this the and new node next part pointing to this, and this is our first element. Now this is the second, and this is the third, this is the fourth, and at last this is the fifth element. Okay, so that's all from this video. In the next video I want to tell you how to delete at any position element, that means any node from the linked list. I can delete this node also, this node also, and this node also. Any node I can delete any node from linked list. In this upcoming video I want to tell you that, and uneasily I understand you. Thanks for seeing this video. Please share and subscribe.